Scientists have achieved what once seemed impossible: reversing time in quantum systems. Quantum time reversal involves manipulating quantum systems to revert to previous states through experimental techniques. The breakthrough connects fantasy of quantum time travel with real scientific advances, allowing tiny quantum particles to return to their early states with remarkable precision. The study, titled Quantum Breakthrough Enables Scientists to Reverse the Flow of Time in Quantum Systems, was published on June 4th, 2025. This research opens a new possibility for quantum computing and fundamental physics research. Have scientists reversed the arrow of time, John?
I don't know. So this is interesting. So just to kind of the experiment that they did. So let's dive into this. So they used a device called a quantum switch and a sophisticated optical equipment. And they were able to make a photon return to its exact state before it underwent any changes. So think of it like this. It's like watching a movie scene in reverse, except the particle genuinely travels backwards through its quantum evolution without the scientists needing to know what happened to it in between. I'm thinking of the movie Tenet as I explain that. So why this matters, right? So the discovery actually could revolutionize quantum computing. And the way it can do that is by providing an undo button for quantum errors. Because when quantum errors make a mistake, which happens frequently due to their extreme sensitivity, this technology could automatically reverse the error without needing to know what went wrong, which is crazy. It also challenges our fundamental understanding of time's arrow and opens new possibilities for quantum technologies. Now, there's a lot of limitations here. While amazing for particles, this technology can't reverse time for humans or large objects yet. The scientists estimate it would take millions of years to rewind just 1 second of a human's quantum state due to the enormous amount of information involved. So no DeLorean Back to the Future stuff, at least not yet. What are your thoughts?
Well, you got to start somewhere.
Yeah.
And, now researchers can now select a specific earlier quantum state to revert particles back to. So it feels, again, magic. Try something, nope, go back, try something, nope, go back. It's almost like life is like a video game with a save button,
It's like a Control Z, yeah.
And undo, right? You go, say, I'm going to save it here, and then I'm going to try this. Oh, I didn't like that. Let's go back to my save point. Let's try this. Didn't like that. And now if you can do that with the real world and physics, this becomes interesting. But we're talking about quantum states. And that we can now go back 95% with 95% accuracy. This is really interesting. And the fact that error states have always been the bane of quantum computing. And since the beginning, it has been hard to tell whether you actually got a right answer or it was just another error and it just got the right answer by accident. So knowing that now we can detect them and automatically reverse them without even knowing what it was, potentially, and build that into these quantum chips, I think is a major breakthrough. It's going to be a game changer for all of this.
I agree. Yeah. And you and I have a different visibility on this because of all the technologies we've covered and advances we've covered in quantums. So beyond quantum computing, though, the time reversal protocol actually has potential applications across quantum technologies themselves. So, for example, in quantum cryptography, the ability to reverse quantum states could enhance security protocols or even enable new forms of quantum communication. For example, in quantum sensing and metrology, time reversal could be used to enhance precision by canceling out unwanted environmental effects. The protocol's ability to work without knowledge of the system's internal dynamics, it makes it valuable for characterizing unknown quantum systems, which could accelerate quantum technology development by providing a tool for probing and understanding new quantum materials or devices without requiring detailed theoretical models. There's a lot more applications than just quantum computing, which is great. But I think that the big thing about this one is this research challenges our understanding of why time has a preferred direction, right? Which I think is crazy. And there's a lot of people who are saying time is not linear and all this sort of stuff, but I don't know. I don't know enough to have an opinion on that. What about you?
Again, I don't know enough to say
Yeah.
time's not reversed, whatever. Like all the rules that we previously thought around science and the world and laws have all been broken at some point in time. Maybe not all of them, but they've changed. So it's going to change again because, like, I foolishly say that quantum is magic. We don't really understand it yet, but it can do things in the physical world that are completely unexplainable. So as we start to traditional physics, not necessarily quantum physics. So as we jump to this new level of understanding of how the universe works, we're going to have these like magic discoveries. So I'm really interested in this because when you start looking at quantum computing and a lot of limitations, a lot of the quantum computing power goes to error control. So we've talked about this, we have 4 chips or 4 qubits that do processing and 3 qubits that do error correction. Great. If you can start now saying maybe we can eliminate a lot of that because we can detect and go back with these reversals, error correction through time reversal represents a paradigm shift in computational strategies. We may be able to bump up our time significantly. And this is a universal qubit compatibility, which is differentiates itself from earlier stuff. So this has more wide approaches than anything that has happened before because it's compatible universally with the qubits out there. So this discovery may influence broader theories about time's nature and physics that we have yet to understand, but I'm really interested in following this and what it means. Like you say, it's nowhere near, we're not going to be able to send a human back in time anytime soon. But that doesn't mean that's not possible 100 years from now or 1,000 years from now. But we talked about those time travel theories before that you can't go back in time before the time travel machine was made based on, these theories. But that might be proven to be incorrect too.
Exactly. Yeah, you never know. Like these theories, until we can actually test them in the real world, are just theories. That's all they are. So theories are disproven all the time. So you never know.
So we'd love to know what you think about the quantum computing, the time reversal, qubits, error correction, and what this means for quantum systems and what it means for the physical world going forward. Are we going to now have laptop computers that have quantum in it that can reverse any errors in programming, logic, all that kind of stuff, or do some things that we never thought possible in the future? We'd love to hear what your thoughts are. Leave your comments below. So, what do you got going on, John?
Yeah, so coming out in September, definitely gearing up for Elevate. I know you're a partner with Elevate, aren't you, Craig?
Oh yeah, absolutely. So definitely we'll be doing something during the Elevate a week, probably a Flowgrammer event, if nothing else. They're a partner of ours. Definitely go out and check it out. There's a lot of great events going on related to Elevate. That's why I said great events, sessions, program. Check out their schedule. Check out all the different lines of programs and stuff. There's always good things there. So definitely go check out Elevate. And check out Toronto Starts for our startup drinks, our startup investor drinks, and our Flowgrammer events where we help people learn how to automate things in their business. And John, if people need funding, where do they go?
Yeah, come find me on LinkedIn. I just posted some news about the Shred program, but come find me on LinkedIn, send me a message, and we'll set up, we'll talk and see if it makes sense to find some non-dilutive funding for you.
Really appreciate everyone taking their time to watch or listen to this week. We'll see you again soon.
Thank you.